So we have touched on them a little bit. We saw a few questions on our homework where we had to, evaluate like 27 to the 2/3 power or something like that. So we talked about how fraction exponents are a way of writing radicals. So the first thing I just want to review is make sure we know how to go back and forth between exponential and radical form. So exponential means it's written as an exponent. Radical is when it's written as a radical. So if I ask you to write x to the 3/5 in radical form, that means I need to write it with a radical instead of the exponent. So what would I say?
5th root of x cubed.
Does it matter if the cube is under the radical or outside? No, it can be either. So you could write it like this or this. You don't have to have both. Just one equivalent form is sufficient. All right? So if I said you have the 7th root of y to the 10th, what would that be in exponential form? Remember, the index on the radical becomes your denominator. Is that okay? Let's look at some problems. I want to reduce each radical here. What do you think the first one would be?
7.
7. So in general, we say a square root and a square cancel, but the definition of a square root, it's the positive root. So if you think about this, -7 squared, -7 times -7 is positive 49, and the square root of positive 49 is positive 7. So the number coming out from underneath a square root would always be positive. All right, B. This is all one term because it's multiplied together. So we can do the cube root of all those individual pieces. So the cube root of 64. What to the 3rd power equals 64? 4. Yep. Everybody have a calculator if you need one. You can grab one off the counter. All right, if you have the cube root of 8 is 6. So that's like saying we have 6 A's. How many groups of 3 could we form? 2. Are there any leftovers? All right, cube root of b to the 15. If we have 15 b's, how many groups of 3? 5. It's just like dividing those exponents. 15 divided by 3 is 5. 6 divided by 3 is 2. So we get 4a squared b to the 5th. Last one. Negative. So this is one term because it's a fraction. So we just do the 4th root at the top and the 4th root at the bottom. So what to the 4th power equals 625?
5.
What to the 4th equals 81? 3. So we get -5/3. So we can handle that. So let's look at this one. I want to reduce all of these radicals. The 4th root of 32. Does anything to the 4th power equal 32? No. So we have to break that down. just like if I had said the square root of 8, you would think, okay, I could break that into a 4 and 2. Square root of 4 is 2, so it's 2 square root of 2. We're going to do the same thing with a fourth root. So you have to think about what is a perfect root that would go into 32. So think about things to the fourth power. 2 to the fourth power is 16. 3 to the fourth, 81. 4 to the fourth, 256. So we're thinking about these numbers. Is 32 divisible by any of them?
16.
So we can break it into a 16 and a 2. The fourth root of 16 is 2. And we still have a fourth root of 2. A common mistake, don't drop the fourth root on your final answer. And also make sure that 4 is written small. Sometimes I see answers that look like this. And it looks almost like a 24 radical 2, so just make sure I can clearly read your answers. Alright, B. So, one term we can break it up. Because it's fraction, we can do the top and we can do the bottom. So the cube root of b squared. If we have 2 b's, do we have enough to form a group of 3? No, so it just stays under the radical. On the bottom, if I have c to the 9th, can I reduce that? Yes. 9 divided by 3 is 3. If we have 9 of them, we can make 3 groups of 3. C. 18. How would I break that up? So it's a square root, so I'm just looking for a perfect square. Square root of 9 is 3. So 3 comes out, and I still have a 2 under my square root. All right, if I have 5 x's, how many groups of 2 can we form? 2 groups of 2. How many are left over? So an x squared comes out, and an x stays underneath. If I have 7 y's, how many groups of 2 can I form? How many left over? 4th root of a to the 7th. So we can break this up. If you have 7 a's, how many groups of 4 can you form? And how many will be left over? So 1a comes out. That accounts for 1 group of 4. And there would be 3 left. If we have 10 b's, how many groups of 4? Okay, that accounts for 8 of them. So there are 2 left under the radical. We have 8 c's. How many groups of 4? Does everyone understand where I'm getting? Any questions for me so far? Do you guys want to try a couple? $24. Is that a perfect cube? What perfect cube goes into it?
8.
That's cube root of 8 times cube root of 3. So cube root of 8 is 2, so a 2 comes out. We have a cube root of 3 still underneath. If you have 5 a's, how many groups of 3? how many left over? If you have 10 B's, how many groups of 3? How many left over? Did you guys get that one? B, 48. Does something to the 4th power equal 48? Okay. So you can break it into a 16 and a 3. So 4 through 16 is 2, so 2 comes out, 3 stays under. If you have 9 x's, how many groups of 4?
2. I knew that.
How many left over? Okay. I left way too much space there, didn't I? Underneath. If I have 12 y's, how many groups of 4? And there are none left over, so that radical's gone. C, square root of 50. What did you break? So square root of 25 is 5. 2 stays underneath. If you have 1a, is that enough to pull it out? So that stays. I have 5 b's, so that would make 2 groups of 2 with 1 left over. On the bottom, the square root of 9. And c, the 20th. How are we doing with those? Good? Let's keep looking at some radical problems. So we're doing pretty good with breaking down just basic radicals. So we want to extend this. What would I do here?
So I guess you'd take the cube root of 27 first.
Radicals are kind of like parentheses. You start on the inside. Cube root of 27, that is a perfect cube, isn't it? The square root just stays. The cube root of 27 is 3. Can we do the square root of 3? Nope, so we're done. We simplified it as far as it could go. How do you multiply square roots together?
Don't they have to have the same, like, what's the thing inside the radical?
The radicand? To add them, the radicand has to be the same. To multiply, the index just has to match, which these are both square roots. So we can multiply and our answer will just remain a square root. And then you multiply the things together underneath. So 6 times 7 is 42. A times A would be A squared B. Can we break down the square root of 42? No. If you have A squared, we can make 1 group of 2, so 1A comes out. So we have A square root of 42. What do I do on this one? So if we multiply 3 times 2, you multiply the numbers outside the radicals together, so that would be a 6. Square root, you multiply the things under the radical together, so square root of 5 is 25. minus, we multiply those 2's together because they're both outside the radical. So minus 4 radical 5 minus 2. Alright, what is the square root of 25? So this means 6 times 5. To add these, since it's the same thing under the radicals, you just combine the coefficients. So 3 minus 4, negative 1 radical 5. And then I can combine my 30 minus 2. So I get 28 minus the square root of 5. Alright, can I add all these together yet? No, they're all cube roots. However, it's not the same thing under the radicals, so we can't combine them. We need to try to reduce our radicals first. So cube root of 16. Are there any perfect cubes that go into 16? 8 and 2. So this is like a 5 times, what's the cube root of 8? 2 times the cube root of 2. So that term would turn into 10 cube root of 2. So the number that comes out multiplies with our coefficient. Alright, cube root of 54. Can we break that down? And 2. Cube root of 27 is 3. We already had 3 out there. So we get 9 cube root of 2. And last one, 4 cube root of 2. Can we reduce that? No. What do you notice about all of these now? So now you can combine the coefficients. It's just like when you add x's. 9x plus 10x. The x doesn't change, so the cube root of 2 doesn't change, just the coefficient. So 10 plus 9 minus 4 would be 15 cube root of 2. So it's okay? Why don't we stop here for today? We'll do this Monday because we want to start class tomorrow. So the assignment, there is a handout posted on Google Classroom. This is the assignment for the entire section. So that means if I'm going to finish the section Monday, this will be due on Tuesday. You can do quite a bit of it already. Really, you could probably do everything except the last 4 problems if you really chose to. So, you could do 1 through 19 if you wanted to go that far. We'll finish it Monday.